Hi everyone, welcome to the section on K nearest neighbor algorithm, or in short KNN algorithm. So this is the algorithm which is used to classify the test sample between the classes. So we will use this algorithm for the classification purpose. So K in this algorithm is an integer. We usually select the odd value of K, that is 3, 1, 5, 7 and so on. By selecting an odd value, it is easy to perform the majority voting at the end. So we will see also what is the advantage of selecting the odd value of the K. So let's see what we are going to learn in this section. So these are the topics which we are going to cover. First, we will learn the concept or the intuition behind KNN algorithm. We will see how this algorithm works and what are our requirements from this algorithm. Then we will study KNN algorithm. We will study all the steps in order to implement KNN algorithm. Then I will apply KNN algorithm to a numerical example. That is, I will solve a numerical example based on KNN algorithm so that we can get the best understanding of KNN algorithm. Then we will discuss the advantages and disadvantages of KNN algorithm. And finally, we will implement all the concept of KNN algorithm in Python with the help of 4 projects. So you will find this section very knowledgeable and interesting. Thanks for listening, and I will see you in the next lecture of this section. Hi everyone, welcome to this lecture. So in this lecture, we will learn about the intuition behind KNN, or basically we will learn how KNN works. So suppose we have two classes of a data. So this is the data which has been divided into two classes. This is our class A, which is represented by a blue color, and we have a green color of class B. Now a new point comes, which is our new test point or our query point. So this is shown with the red color. Now how KNN works in order to classify this point between two labels, that is between the class A and class B. So we have to decide about this point, whether this belongs to class A or it belongs to class B. So let's see how KNN works about this point. So what KNN can do is KNN will assign the nearest neighbor to the point. So in the first step, KNN will assign one nearest neighbor to this testing point. So this red is our testing point, and according to KNN, this green is the nearest point to this red point. So it will assign one nearest neighbor to this point, and based on that point, it will decide in the favor of the class. Since the nearest point to this test point belongs to class B, therefore, according to this classification, this test data belongs to class B. Now, what could be the problem when K is equals to 1, or what could be the problem with only one nearest neighbor? Suppose our testing point is here, and in our data set, there is also a misclassification. So we can see that this green point is a misclassified point. It belongs to class A according to the classifier. However, its original label is class B. So what happened? If our test point is at this position and we select only one nearest neighbor, in that case, we will not be able to classify it correctly. Clearly, we can see that this red point is close to the cluster of class A as compared to class B. But since we have selected only one nearest neighbor, so according to one nearest neighbor, this test point belongs to class B because its nearest point belongs to class B. So this is again the problem by selecting a very less number of nearest number, that your nearest neighbor may be the misclassified point or any noise which is present in the data. So this problem is solved by increasing the number of nearest neighbors. So we can see that here we have 3 nearest neighbor. So if we select 3 nearest neighbor, so in those 3 nearest neighbor, one of the neighbor belongs to class B and 2 neighbor belongs to class A. So if we perform the majority voting here, so according to the majority voting, the two samples or two nearest neighbor belongs to class A. Therefore, this testing point belongs to class. So here the classification of the classifier is correct by increasing the number of nearest neighbor. So based on the majority voting, we decide in the favor of class A in this particular figure. Now, when we have 3 nearest neighbor, this is another situation. So we can see that this is our testing point, and when we select 3 nearest neighbor, then based on the majority voting, we can say that this test sample belongs to class A. However, we can see that it is not easy to take 3 nearest neighbor here. This data sample also wants to join the nearest neighbor of this point. So the solution is to increase the number of nearest neighbor. So if we increase the nearest neighbor to 5, so we can see that we may arise these two kind of situation. So in that situation, what is happening? If we see here, these are the 5 nearest neighbor to this testing point. In that case, based on the majority voting, 3 of them belongs to class A and 2 of them belongs to class B. So based on the majority voting, this belongs to class A. If we see here, based on the majority voting, this belongs to class B as compared to class A. So here we can see that even with k is equals to 5, there might be a problem. So how many nearest neighbor we need to select? For this, we have to study the KNN algorithm in detail. So I will see you in the next lecture. Hi everyone, welcome to this lecture. So in this lecture, we will learn about the KNN algorithm. Basically, we will see what are the important steps of KNN algorithm and how we can implement KNN algorithm. So these are the 4 important steps of KNN algorithm. So the first step is choose the number of nearest neighbor, that is the value of k. Okay, suppose we have selected k is equals to 5. So this is our first step. So the second step is take the k nearest neighbor of a new data point according to the Euclidean distance. When a new data point comes or when we have a testing point, then we have to select the 5 nearest neighbor if we have already selected k is equals to 5 based on the Euclidean distance. So what does it mean? Suppose this is the situation. We have a new data point. So we will calculate the distance of this new data point with every sample of class A and with every sample of class B using Euclidean distance. So what is the Euclidean distance? So this is the equation of Euclidean distance. Euclidean distance is used to calculate the distance between 2 points. Suppose we have 2 points P1 and P2 and their coordinates are x1, y1 and x2 and y2. In that case, Euclidean distance will be the square root of x2 minus x1 square plus y2 minus y1 square. So this is a simple equation which is known as Euclidean equation in order to calculate the distance between 2 points. So this is our second step of KNN algorithm. That is, after selecting the value of k, we will find the distance of our data of our new point with every sample of our data, whether it belongs to class A and class B. Then based on the distance, we will select the nearest point. If our k is 5, then we will select 5 those points which are near to the test point based on the Euclidean distance. That is, those 5 points which has the minimum distance with our test point. Okay, now step 3 and step 4. When we have selected the k neighbors or 5 neighbors as we have selected in step 5, then we count the number of data points in each class and assign the new data point to the class where you counted the most neighbor. Since we have selected k is equals to 5 in order to understand KNN algorithm, so we will select the 5 neighbors. Okay, if out of 5 neighbors, 3 belongs to class A and 2 belongs to class B, in that case, we will decide in the favor of class A according to point 4. So here is the complete explanation of KNN algorithm. The first step is to select the value of k. We have selected k is equals to 5. The second step is to calculate the distance of our new point with all the points present in class A and in class B. So this distance will be calculated with the help of Euclidean distance. Based on the distance, we select the 5 neighbors. So these were the 5 neighbors. Now, among those 5 neighbors, we will perform the majority voting. We see here 3 of the neighbors belongs to class A and 2 neighbors belongs to class B. So we will decide in the favor of class A here. So in this lecture, we learn about a simple algorithm which is known as KNN algorithm. We studied that this is a very simple algorithm to implement. It has only 4 steps, and here are the explanation of all the 4 steps. Select the value of k, calculate the distance, assign the neighbors, and perform the majority voting in order to select the class of a new point. So I hope you understood the concept of KNN algorithm. Thanks for listening, and I will see you in the next lecture. Hi everyone, welcome to this lecture. So in this lecture, we are going to solve a numerical example on KNN. So this is my data set for the numerical example on KNN. So in the first column, we have the height of the customer. Then in the second column, we have the weight of the customer. And in the third column, we have a t-shirt size. So this data set is about the t-shirt size. We can see that in a t-shirt size, we have 2 kinds of labels, that is M and L. So this column is our label of the data set, or this is our target variable. Now, these are the heights of the customer and these are the weight of the customer. So based on the height and weight of the customer, we will decide about the size of t-shirt. For instance, if the height of the customer is 158 centimeter and weight is 58 kilograms, then we will assign a medium size t-shirt to that customer. Similarly, if we are here, if the height of the customer is 160 centimeter and the weight is 64 centimeter, in that case, we will recommend the large size t-shirt to the customer. So this is the t-shirt dataset. Based on the height and weight of the customer, we recommend the size of the t-shirt to the customer. Now, a new customer, Sarah, has height 161 centimeter and weight 61 kg. What size of t-shirt she needs? It means this is our new data point and the coordinates are 161 and 61, where 161 is the height in centimeter and 61 is the weight in kg. Let's check whether this point is present in our data set or not. So if we go back, we can see that this 61, which is the weight, is present at 2 different places in our data set, but 161 is not present in our data set anywhere in the height column. It means this is a totally new point and we have to apply KNN in order to recommend the size of a t-shirt to the new customer. So what we will do? So we will apply KNN algorithm, and here are the first 2 steps of the KNN algorithm. So we have decided to take the value of k is equals to 5. That is, we have decided to take the nearest neighbors is equals to 5. The second step is that we have to find the Euclidean distance of this new point with all the points in a data set. So we will start with the first point. This is our new point and this is our first point. These are the coordinates of new point 161 and 61, and these are the coordinate of our first data sample 158 by 158. If we go back, we can confirm that this is our first data sample. So we can see that our first data sample has height 158 and weight 58. Now it's time to calculate the distance of this new point with every point which is present in our data set. We know that this is our Euclidean distance. In Euclidean distance, we subtract the x coordinate from the x coordinate and y from the y coordinate. That is, we will subtract 158 from 161, then we will take a square. Then we subtract 58 from 61, then we will take a square. We will add them and we will take the square root. So here is the distance of a new point with the first data sample. Similarly, we calculate the distance of this new point with the second, with the third, and with all the points present in our data set. So here are all the distances. If you see, there is an additional column in the dataset known as a distance. So that is the distance which we have already seen now. This is a distance of a new data point with our first point whose coordinates are 158 by 58. Similarly, this is a distance of a new data point with the second sample. This is the distance with the third sample. This is a distance with the fourth sample. And similarly, this 7.3 is the distance with the last sample. Now, these are all the distances of our new data point with the existing point that are present in the data set. Now, in order to select the 5 nearest neighbor, find the 5 smallest distance. So if we see 1.4, 2.2, 2.2, 2, 3.2, they are the 5 smallest distance of a new data point with the data points that are present in the original data set. So these 5 distances or those points which have these 5 distances with our new points will constitute the nearest neighbor for the new data set. So this is the most closest point, then is this point, then these 2 points have the same distances. So that's why we call it 3, or we can also call it as a 3 and 4. And this is our 5th neighbor. So based on the 5 nearest neighbor, let's check the label and decide on the base of the majority voting. So basically here we are going to perform the step 3 and step 4. So step 3 is to select the nearest neighbor, and step 4 in KNN algorithm is to decide about the class based on the majority voting. So if we see inside the 5 nearest neighbor, we have 4 labels related to the medium size t-shirt. So based on the 5 nearest neighbor, we have decided that the size of a new customer is a medium size, and we will recommend a medium size t-shirt to a new customer whose height is 161 centimeter and weight is 61 kg. Okay, let's see what will happen if we increase the number of nearest neighbor from 5 to 7. So if we select 7 nearest neighbor, we can see that here we have select the 7 minimum distances. So if we select 7 nearest neighbor, in that case, if we go on the majority voting, still there are 5 samples out of 7 which belongs to medium class, and there are only 2 samples belongs to large class. So still in 7 nearest neighbor, we still recommend the size of t-shirt as a medium. So if we increase the nearest neighbor size further and improve and increase it to 9 nearest neighbor, in that case, these are the 9 nearest neighbor. So if we see the labels and if we go for the majority voting, so we have 6 labels which are related to the medium class, and there are 3 labels related to the large class. So based on the majority voting, we can see that we will recommend a medium size t-shirt to a new customer, Sarah. So we can see that whether our nearest neighbor is 9, 7, or 5, the majority voting tells us that the size of a t-shirt for the new customer is a medium size. So in this lecture, we learn how to implement KNN algorithm on some real value problem. We select a numerical example, and based on the KNN algorithm, we decided that the size of t-shirt for a new customer should be a medium size t-shirt. So I hope you understood this numerical example. Thanks for listening, and I will see you in the next lecture. Hi everyone, welcome to this lecture. So in this lecture, we are going to solve our project 1 on KNN. So in this project, we will learn how to implement KNN on the dataset. Now here I am in my Google Drive. Inside my Google Drive, I have my course material folder. Click on this course material folder. I have 3 major folders of my course: Introduction, Supervised Machine Learning, and Unsupervised Machine Learning. Click on Supervised Machine Learning. Inside Supervised Machine Learning, I have KNN. Click on the KNN, and inside KNN, I have project 1, that is Understanding Fundamentals of KNN. So click on this file so that we can open our project 1 in our Google Colab environment. So here I am in my project 1 of KNN. So I need NumPy for this project. I need pandas. I need matplotlib. I also need a function make_blob. This will help us to create the dataset, and I will import it from sklearn.dataset. Similarly, I need k-neighbors classifier, which I will import from sklearn.neighbors. I also need train test split function so that I can split my data into training and testing component. So let's run this cell to import all these Python libraries and Python functions. Now it's time to create the data. So I am going to use a function make_blob in order to create the data. So I have to pass few input parameter. The first of all, how many samples I need. So in the first step, I am passing number of samples is equals to 10. Number of features is equals to 2. Centers is equals to 2. So the centers is equals to 2 means that when I will run this line of code, it will generate a data which belongs to 2 classes. So centers equals to 2 means I need 2 classes for this data set. Cluster standard deviation. This is another important factor. It is 1.5. It sets the spread of the data. Basically, I will generate that data with 2 labels, and the samples belongs to both these 2 labels will be apart from each other. So how far apart those 2 samples are from each other, it will be set by the cluster standard deviation, which is 1.5. So the random state is 42. It means I am passing the random state so that every time I run this line of code, I will get the same samples for my features and for my labels. Let's run this cell to create the data. Let's see the features in the data. So we have 10 features and basically 10 samples, and we have 2 features in our data set. This is the column 1 or feature 1. This is the column 2 and or a feature 2, and we can see that we have total 10 samples. Okay, if we want to confirm the shape, we can confirm the shape by writing x.shape. So we have 10 samples and 2 features. Now we can also check the shape of our labels. So we also have 10 labels. Since we have 10 samples, so for every sample we have a label. Therefore, we have in total 10 labels. Now, how many unique labels we have? So if I run this line of code np.unique and I pass the label, I will get 2 values, that is 0 and 1. So we can see that I have 2 labels, 0 and 1. So basically here I have passed centers is equals to 2. That's why I have 2 label in my data set. So the first part is completed. That is, we have created the data set using a function makeBlock. And when we run this function, we get the value of x and we get the value of y. X is feature and y is our label. After creating the data, it's time to visualize the data. For visualizing the data, I have set the figure size 12 by 8. And now I am going to plot 2 scatter plot. This is the first scatter plot and this is the second scatter plot. If you see here, there is a 1 and there is a 0. Here again, there is a 1 and here there is a 0. So basically, I am going to plot the second feature against the first feature. And again, I am going to plot the second feature against the first feature. Because if we go back, we can see that we have 2 features. So I am going to plot the second feature against the first feature. Now, why there are 2 scatter plots? The reason is that I am going to plot the second feature against the first feature for those values of y or for those values of x which belongs to y equals to 0, that is label 0. And I am going to plot second feature of x against the first feature of x for those values of x which belongs to y is equals to 1. Let's understand the concept of these 2 terms here. So if I write x and then I write y equals to 0, what I will get? Let's see. So I will get 5 features, basically 5 samples. Out of 10, I will get those 5 samples which belongs to label 0. And if I write y is equals to 1 and I pass this into the index of x, I will get those 5 samples which belongs to class 1. So we have total 10 samples, out of which 5 belongs to class 0 and 5 belongs to class 1. Okay, so if I write y is equals to 0 and I pass this as the index of x, I will get those samples of x which belongs to class 0. Okay, and if I pass one more 0 after the comma, it means, let's run this cell, it means I will get those sample of x which belongs to y is equals to 0, but they are present in the first column. If you see these value -3, -0.1, -2.8, -3, -0.1, -2.8, these values are present in the first column. So basically, this means belongs to class 0, and this 0 means present in the first column. So in order to represent first column, we need to write 0 because index in Python start from 0. So if you see here, what is this? It means these are the samples which belongs to class 0 but present in the first column of x. And these are the samples of x belongs to class 0 but present at the second column of x. Similarly, these are the samples of x belongs to class 1 present at the second column, and these are the samples of x belongs to class 1 but present at the first column. So basically, this is the understanding. So what I am going to do in the scatter plot, I am going to plot the second feature against the first feature, but those samples which belongs to class 0, then in the second scatter plot, I am going to plot the second feature against the first feature, but for those values of samples or feature which belongs to label 1. Let's run this cell and visualize the scatter plot. So we can see that we have 5 samples here and we have 5 samples here, and there is a difference between them, which is according to this cluster standard deviation. So we see that by using a make block function, we can create a data set and we can pass any number of samples, any number of features, and any number of cluster and any value of the cluster standard deviation. Then the important thing is how to visualize the data. For visualizing the data, we have to do 2 scatter plot, or we have to plot 2 scatter plot. That is the scatter plot between the second feature and the first feature. Why we need to plot 2 scatter plot? Because the first plot will be the second feature against the first feature for those value of x belongs to class 0, and the second scatter plot is against the plot of a second feature against the first feature with those value of x belongs to class 1. So in this way, in this lecture, we learn how to create the data with the help of an important function make_blobs, and how to visualize the data using a scatter plot. We also learn why we need to plot 2 scatter plot on top of one another. So I hope you understood this lecture. I stop project 1 here. In the next lecture, I will continue my project 1. See you there. Hi everyone, welcome to this lecture. So this lecture is a part 2 of project 1 on KNN. So in part 1, we have already created the dataset using a function makeBlob. After creating a dataset, we visualize the dataset by performing a scatter plot. So this is the scatter plot. Here we plot the second feature against the first feature for those value of x belongs to label 0. And then we have a second scatter plot where we plot the second feature against the first feature for those value of x belongs to class 1. So we can see that for class 0 or for label is equals to 0, we plot in a red color, and the class 1 or label 1 is plotted in a blue color. Now, this is for the understanding of a function makeBlob and for the understanding that how to visualize the data. Now, in order to perform KNN classification, we need more points. So what I am going to do is to generate 1000 points here. Okay, so I am going to generate the 1000 points here. Let's run this cell to generate the 1000 point. And here I can confirm the shape. So the shape is 1000. The features are still 2, and rest all the input parameter for the make blobs are same. The only difference is that I am going to generate the 1000 sample. Okay, similarly, the shape of y is now also 1000, and I still have 2 labels, that is 0 and 1. Now I can visualize the data. If I visualize the data for 1000 sample, we can see that we have a data. We have 500 point in class 0 and 500 points or data points in our class 1. So now the data has been generated and has been visualized. Now it's time to apply KNN classifier, but before the application, we need to split the data into the train test split. So here I am splitting the data. I am passing my features, I am passing my label, and here the test size is 20%. That is, out of the 1000 sample which are present in our data set, I am going to use 20% of a sample as a test and 80% as a training. Here random state is equals to 42. It means every time I run this line of code, I will get the same sample in the training component, in the testing component, and also in the training labels and the testing label. Let's run this cell to split the data. And here we are going to visualize the training data. And here I am going to visualize the test data. So this visualization code is same as we used here. That is, we are going to use 2 scatter plot. So in the first scatter plot, we are going to plot the second column of our training data, which belongs to label 0. And then we are going to plot the second column against the first column of our training data, which belongs to label 1. So this represents the training label, which is equals to 0. And this represents the training label, which is equals to 1. Here the size of this S is equals to 30. This is the size of the samples, and first sample is in red color and second is in blue color. These are the font size. So the X label will be feature 1, feature 2, and the title of the plot is data visualization. Let's run this cell, and we can see that we have a training data. So this is the training component of the data. We can see that we have the training samples belongs to class 0 and training sample belongs to class 1. So we have the plot against the feature 1 and feature 2. Okay, now we can also visualize the testing component of our data. We can see that in the testing component, we have only 20% data. So this belongs to class 0 and this belongs to class 1. So after creating and visualizing the data, we have splitted the data into training and testing component, and we have also visualized the training component and the testing component of a data. Now it's time to apply KNN classifier. For KNN classifier, I will instantiate K neighbors classifier and I will call it as KNN. Let's run this cell to instantiate our classifier. Here I am fitting my classifier to the training component. Fitting means that I am going to train my KNN classifier from the training data. And here I am getting the predictions from the testing data. Let's run this cell. So I have the prediction, and here I can calculate the accuracy easily by comparing the prediction of the model with the actual labels. Let's run this cell. So we can see that the accuracy is 100%. Okay, now visualizing the data predicted by the KNN classifier. So here I am passing ypred is equals to 0. That is, those predicted labels belongs to class 0 and ypred is equals to 1. And I am passing this index to my testing component. Let's run this cell. So we can see that this is the predicted data. If we compare, this is the predicted data by the model. If we compare the predicted data with the testing component, it is exactly the same. You can see it is exactly the same. That's why our accuracy is 100%. The other reason is, if we see the testing data, there is a gap between the testing data. It means the testing components are well separated both for class 0 and class 1. That's why we are getting a very high accuracy. There is no mix-up. There is no overlapping between the samples of class 0 and class 1. They are well apart even in the testing form. That's why our model has classified them very easily. And if you see the classification, if you see the predicted samples, they are exactly the same as that of testing. That's why our accuracy is 100%. Okay, let's generate more challenging data. So for more challenging data, what I am going to do, I am going to do first is that I am going to create 3 centers. That is, centers is equals to 3, and I am also going to set the standard deviation is equals to 3.5. Let's run this cell to create more challenging data again by using a function make blobs. Let's see the shape. Now the shape is again 1000 by 2. Let's check the unique labels. Now we have 3 unique labels. That is 0, 1, and 2. So since we have 3 unique labels, now in order to visualize the data, I have to perform 3 scatter plot. That is, for those value of x belongs to y equals to 0, for those values of x belongs to y is equals to 1, and for those value of x belongs y is equals to 2. And here I am using red, blue, and green color. Why we are going to plot 3 scatter plot? Because we have 3 labels. So the data belongs to class 0 or label 0 will be of red color. Data belongs to class 1 will be of blue color, and data belongs to class 2 or label 2 will be of green color. Rest the code is same. On X label, we are labeling feature 1. On Y label, we are labeling feature 2, and the title is data visualization. Okay, let's run this cell to visualize the more challenging data. Now this is the more challenging data. Here we can see the overlapping of the data samples. So data belongs to different classes are overlapping each other. Okay. Now again split the data into test and train. Again, we are going to select 20% of the data from this challenging data set into the testing and remaining 80% as a training. Let's run this cell to perform the train test split. Here I am standardizing the data. And for standardizing, I am importing standard scalar from sklearn.preprocessing. Here I am instantiating my standard scalar with the variable sc. Here I am fitting my standard scalar and transforming to the training component. And here I am applying my standard scalar, or I am standardize my testing component of the data. Let's run this cell to standardize both the training and the testing components of data. It's time to visualize. Here I am only visualizing the testing component of this challenging data set. Let's run this cell. Now we can see that in the testing component, again, all these clusters are not well separated. They are mixing each other. That is, the three classes are mixing with each other. Their data samples are not well separated. They are overlapping. So that is going to be a challenge for KNN classifier. And now we are expecting the accuracy of less than 100%, because we are expecting few misclassification from KNN classifier, because this is the more challenging data set. Now applying KNN classifier, this time I am calling it KNN_2, because this is our second classifier of this project. Let's run this cell to instantiate the classifier. Here I am fitting my KNN classifier to the training component. That is, I am training my model on the training component, and then I am getting the prediction from the testing component of a data. And here I am comparing the prediction of the model with the actual label of a testing data. Let's run this cell to see the accuracy. Now we can see that our accuracy is dropped by 7.5%. Let's visualize the predicting data. So if we visualize the predicting data, we can see that model has few misclassification, especially about this point. According to model, this point belongs to this red label, although it belongs to the blue label. Similarly, we can see the classification or the misclassification here. So most of the misclassification is between this red label and between this blue label, that is the class 0 and class 1. That's why we can see that the accuracy is less than 100%, that is, it is 92.5. So in this project, we learn how to perform KNN classification on a data set. The first data set we created was a very simple data set where all the labels are well separated, and our KNN classifier perform really well, and we get the accuracy exactly equals to 100%. Then in order to check the further performance of KNN classifier, what we did is that we created the more challenging data set where we saw the overlapping between the data samples of different classes. Then we perform KNN classification again on this challenging data set where there was overlapping of the data samples between the classes. We saw that our KNN classifier also performed well and try to predict the samples well, but its accuracy is decreased from 100% to 92.5% because of the challenging data set, because of the overlapping of the data samples. So I hope you understood the basic concept behind KNN. You understood the concept how KNN classify the data, when KNN performs well, and when there is misclassification from the KNN classifier. So I hope you understood this project 1. Thanks for listening, and I will see you in the next lecture. Hi everyone, welcome to this lecture. In this lecture, we will learn how to find the optimal value of K. Previously, we have selected the value of K manually. If you remember, in the numerical example of KNN, we select the value of K equals to 5. So that was the manual selection. Now here, we will learn how to find the optimal value of K with some algorithm or with some method. So we will find the optimal value of K using this plot known as error rate plot. So this is the error rate plot. Here we plot the error rate against the number of nearest neighbor. So here we have provided the list of the nearest number, which is from 1 to 30. And based on the value of the nearest neighbor, we will calculate the 30 value of the error rate, and we will select that nearest neighbor which has the minimum error rate. Okay, we are starting from here. Here K is equals to 1. That is, if we select nearest neighbor is equals to 1, that is only one nearest neighbor, that is K is equals to 1. When K is equals to 1, this is the value of error rate which is between 0.07 and 0.08. When k is equals to 2, the error rate is still same. Then k is equals to 3, 4, 5, 6, 7, 8, and we move on. Here we can see that when k is equals to 15, the value of error rate is minimum for the very first time. It is still minimum for 16, 17, 18, 19, 20, and 21. But k is equals to 15 is the first time when we get the minimum value of error rate. So we will select k is equals to 15 for this particular problem. So what is error rate basically? So error rate is very simple to calculate. It is 1 minus accuracy. If your accuracy is 90% or 0.9, then the error rate is 0.1. That is, if your accuracy is 0.9, you will subtract 0.9 from 1, you will get the value of error rate, which is 0.1. Similarly, if your accuracy is 100%, it means this value is 1. In that case, you will not have any error rate. So basically, what you will do, you will find the error rate for k is equals to 1, then for k is equals to 2. So you will train your model for every value of k, and then you calculate the error rate, and then you plot the error rate. From the plot, you can easily find the point or the value of k for which the error rate is minimum, and that point will be selected. So I hope you understood this concept of selecting the optimal value of k, and we are going to use this concept in our coming projects, that is project 2, project 3, and project 4. So I will see you in those projects. Thanks for listening. Hi everyone, welcome to this lecture. So in this lecture, we are going to solve our project 2 on KNN classifier. So basically in this project, we are going to learn how to find the optimal value of k in order to perform the KNN classification. So here I am inside my KNN folder, and this is my project 2, which is inside my KNN folder. Let's click on this file so that we can open it in our Google Colab environment. So here I am in my project 2. So for project 2, I need pandas, I need matplotlib, I need kfold. Basically, I am also going to perform grid search cross validation for KNN in this project as well. Therefore, I need a kfold, I need grid search cross validation, I need train test split, I need k neighbors classifier, and I also need a function make_blob in order to create the dataset. Let's run this cell in order to import all these necessary Python libraries. So I have imported all these libraries. Now I am creating a dataset. Here I am again going to create the challenging dataset with 3 labels and with standard deviation is equals to 3.5. I have 1000 samples. I have 2 features. So let's run this cell to create the data. Here I can see the shape of my data. My features especially, which is 1000 by 2. So I have 1000 samples with 2 features. Okay, and how many unique labels? So I have 3 classes, 0, 1, and 2. Here I can visualize my data. So this is my data visualization. We can see that we have 1000 samples divided into 3 labels. We have class 0, which is of red color. We have class 1 in blue color, and we have class 2 in green color. So we have 3 classes basically labeled as 0, 1, and 2. So this is the scatter plot of my data. Now I am splitting the data into testing and training component. I am using 20% of my data as a testing. It means remaining 80% will be used as a training. So let's run this cell to split the data. Here I am standardizing the data. Here I am standardizing my training component of the data. And here I am standardizing my testing component of a data. Let's run this cell to standardize the data. Now it's time to visualizing the testing data. So if I want to visualize the test data, we can see that there are quite a few number of samples which are mixing, especially for class 0 and for class 1. Okay, now it's time to apply KNN classifier. So if I run this cell, I will be able to instantiate the KNN classifier. If you see here, I did not pass any number of nearest neighbor. So I did not pass any input parameter or any number of a nearest neighbor. Let's see what is the default value. So in order to check the default value, I have to pass this function k neighbors classifier into the help function. So I have to call a help function on K neighbors classifier. On my K neighbors classifier. It's not a regressor. We need a classifier. Okay. So let's run this cell. And we have to also, okay. So let's run this cell to call the help function. Okay, let's scroll up. So we can see this is K neighbors classifier and the default value is 5. So basically this KNN classifier is using 5 neighbors in order to classify the test data. So this is the default value which we have been using from the project one. Okay, let's start with the default value. Let's uncommit this so that I can save the space. Okay, so it means when I instantiate K neighbor classifier, the number of neighbors are 5 here. Okay, here I am fitting my model to the training component. That is, I am training my model on the training component. And here I am getting the prediction from the testing component. Okay, now I have the predictions by the model. I compare the predictions of the model with actual test label so that I can calculate the accuracy, and we can see that this is the accuracy 92.5%. So this is the same accuracy which we obtained in project one for this challenging data set. And now we can visualize the predictions. So we can see that these are the data visualization. These are the predicted data by the model. So we can see that there are quite a few misclassification. That's why accuracy is 92.5%. Now we have to improve this accuracy. In order to improve this accuracy, we have to find the optimal value of K. Now we are not going to use the default value of K, which is 5. So we see in the document of KNN classifier, that is the default value of K, which is called nearest neighbor, is 5. Now, how to find the optimal value of K? In order to find the optimal value of K, we have to use error rate plot. What is error rate? So error rate is the difference between the 100% accuracy or the actual accuracy. Basically, it is the difference that how accuracy or how much accuracy is far apart from being 100%. Suppose the accuracy is 90%. In that case, the error rate will be 10%. If accuracy is 99%, in that case, error rate will be 1%. So it is the difference between the 100% value for the accuracy and the actual value of the accuracy. Okay, let's plot the error rate in order to find the optimal value of K. So the first step is that we set the empty list for the error rate. Here I am running a for loop for 30 different values of the neighbors. Okay, for 30 different value of the neighbors, I will select that value of K which will have the lowest value of the error rate. Okay, so here I am instantiating my classifier. This is K neighbors classifier. Here I am passing number of neighbors is equals to I. So the first time this loop will run, the value of neighbor will be 1, and then I will calculate the error rate. Then I will be 2 and I will calculate the error rate. So I will calculate the error rate for 30 different value of nearest neighbor, and I will select that value of nearest neighbor for which the error rate will be minimum. So here I am instantiating, and here I am fitting my classifier to the training component. Here I am getting the prediction, and here I am comparing the prediction with the actual testing label so that I can get the accuracy. Here you can see that I am subtracting accuracy from 1 in order to get the error rate value. And here I am appending the error rate value to the error rate so that I can get the 30 error rate value. So the concept is basically here, the error rate is 1 minus accuracy. If accuracy is 0.9, then the error rate value will be 0.1. So I am instantiating my classifier. I am fitting my classifier to the training component. I am getting, after training the model, I am getting the predictions from the model. Here I am calculating the accuracy, and here I am calculating the value of error rate, and here I am appending the error rate to my list. Okay, let's run this cell. And now it's time to plot these 30 value. Here I am plotting error rate against the 30 value of nearest neighbor. So the color is magenta, the line width is 3. This is my marker, and this is my marker face color, and the marker size is 10. So this is the title, this is the X label, that is number of nearest neighbor, and this is my Y label, that is error rate. Okay, this is very standard stuff. So let's run this cell and see the plot. Okay, this is my error rate plot. So we can see that when the number of nearest neighbor is 1, this is the value of error rate between 0.07 and 0.08. Then it goes up and then again is starting to go down. So the first time it reached to the minimum value is when the number of nearest neighbor is 15, and then it continue till the value equals to 21 or 22 here. Basically it seems like it is 21. Okay, now the first time we reach to the minimum value of error rate is when the number of nearest neighbor is 15. It means now we are going to select the nearest neighbor is equals to 15. With this value, I am again going to train my KNN model on the same challenging data, and I will see whether the accuracy is improved or not. So you can see here, I am again going to instantiate my KNN classifier. This time, the number of nearest neighbor is 15, and I am calling it KNN underscore 15. Let's run this cell to instantiate the classifier with neighbors is equals to 15. Here I am training my new KNN classifier on the training component, and here I am getting the prediction from the testing component. Let's run this cell, and now I am comparing the prediction of the model with nearest neighbor is equals to 15 to my actual testing sample. Let's run this cell to see the accuracy. So we can see that we have improved the accuracy in a considerable amount, that is by 2.5%. Without selecting the optimal value of K, the accuracy was 92.5%. And after selecting the optimal value of K using error rate plot, our accuracy has improved to 95%. So in this way, we learn it's better to select the optimum value of K using the error rate plot in order to get the best performance from the KNN classifier. Okay, there is another method of finding the value of K or finding the value, optimal value of K using grid search cross validation method. Let's see how this method works. So for this, I am using K is equals to 5. That is the number of split for cross validation is equals to 5. Let's run this cell. And here I am again instantiating my KNN classifier, and I am calling it model. Now here I am passing the input parameters to the model so that it can select the best value of the parameter. So there is only one parameter for KNN classifier, which is the most important parameter, that is the number of neighbors. And here I am passing 30 different values from 1 to 30 in the form of list. And here I am training my model. Here I am passing those parameters here in a grid search cross validation. The input is model. Here I am passing the parameter grid, which is the parameters of KNN, that is this value, and my cross validation is equals to CV, and the split is 5. So basically I am going to perform grid search cross validation on KNN classifier. For this grid search, I have only one parameter, which is n neighbors, and I am calling it param kn, and here I am passing a grid search function. The first input is a model, then the parameters, and then the cross validation. Here I am fitting this model to the training component so that I can get the best parameter, and here I am observing the best parameter. Let's run this cell to get the best parameter. So grid search CV is saying that the best value of nearest neighbor is 25. From the error rate, we observe that the best value is 15, but grid search cross validation is saying the best value is 25. Okay, let's calculate the prediction when nearest neighbor is 25. Let's run this cell and now compare the prediction of grid search cross validation with the actual label of testing component. Let's run this cell. We can see that our accuracy is 94%. Now this accuracy is 1% less than those classifier or that classifier which is selected by the error rate, but this 94% is still larger than this 92.5% where we did not select the optimal value of K but use the default value of K. So we learned that there are two methods in order to select the optimum value of k, whether we use error rate plot or we use grid search CV. The performance is very close. With error rate plot, we got the 95% accuracy, and with grid search, we got 94% accuracy. Okay, let's create the confusion matrix for accuracy is equals to 95%. That is for the model which was generated by error rate plot. Here are the font values for the confusion matrix. Here I am importing confusion matrix, F1 score, precision, recall, accuracy score, and confusion metric display from sklearn.matrix. And here I am getting the figure or the image of my confusion matrix. So we can see that this is our confusion matrix of 3 classes. So the values along the diagonal of confusion matrix always show the correct classification. So this 5 is a misclassification. This 5 is this 0 are also representing, that is, there is no misclassification here. There are 3 misclassified value for this label, which is 1, and there are 2 misclassification here for label equals to 2, and there are 5 misclassification for label is equals to 0. So that's why there are few misclassified value which are not along the diagonal, they are outside the diagonal of this confusion matrix. The diagonal of the confusion matrix always represent those samples which are classified correctly by the model. So since there are few classifications, misclassifications, that's why our accuracy has reduced to 95%. Now here we can calculate the precision, recall, and F1 score as well. So you have seen this code many times now in this course. So this is very standard stuff, and we can see that the accuracy is 95%, the precision, recall, and F1 score are also approximately 95%. So student, in this project, you learn how to find the optimal value of K in order to get the best possible performance of KNN classifier. We learned that there are 2 different methods in order to find the optimal value of K. The first method is using error rate plot, and the second method is using grid search cross validation. So you can use any of the method because the performance of both these methods are very close to each other. So I hope you understood this lecture. I hope you understood this project very well. Thanks for listening, and I will see you in the next lecture. Hi everyone, welcome to this lecture. So in this lecture, we are going to solve our project 3 on KNN classification. So here I am inside the folder of KNN. This is my project 3. So project 3 is on wine data. So basically we are going to perform KNN classification on wine data in this project. So click on this file so that we can open it in our Google Colab environment. So here I am in my project 3. So for my project 3, I need NumPy, I need pandas, I need matplotlib. Similarly, I need to import k-neighbor classifier from sklearn.neighbors, and I also need train test split. Okay, let's run this cell to import all these important Python modules. Okay, now it's time to get the data. So I am getting the data from datasets. So what I am going to do is I am importing datasets from sklearn, and then from datasets, I am going to load a wine data, and I am calling the data name as a wine as well. Okay, let's run this cell. So I have successfully importing the dataset called as a wine data. Let's see the data. Now here the data is in a different form. That is, if you see, this is the data, and these are the targets. So these are present inside the dictionary. Like you can see that this is the dictionary here, and this is our key, and these are our value. So this data is representing basically the features of the data, and these targets are representing the labels of the data. And we can see that we have 3 labels, 0, 1, and 2. And based on the 3 labels, we have the target names as class 0, class 1, and class 2. Okay, the more important thing is we have the feature names. So we have the feature name alcohol, malic acid, and so on. So based on these features, we have the quality of wine. So basically our wine is of 3 quality. That is, the quality belongs to class 0, class 1, class 2, based on these features. So we have a wine data set, we have a feature, we have the targets. So basically we have 3 targets. Okay, let's explore this data further. So if I want to see the feature name, I have to write wine.feature_name, because I can see here this variable is feature underscore name, and it is inside the vine. So vine dot feature underscore name. Let's print the feature name. So these are the same feature name which we have seen here. Okay. If I want to print the target names, so I can see the target names are class 0, class 1, and class 2. If I want to see the data shape, now this is very important. Basically, this is the shape of my features for this data set. Okay, so we can see that we have 178 sample in this data set, and we have 13 features. There are quite a lot of feature in this data set. Let's see the wine targets. So if we see wine target, we have 0 label or target, we have 1, and we have 2. So we have already checked that we have 3 classes, class 0, class 1, and class 2. Okay, now wine target shape. So since we have 178 features, so we also have 178 labels. Now let extract features and labels. So calling the features as X and label as Y, that is in the standard format. So let's run this cell. So wine.data are our feature. We can also confirm from here the data are our features and targets are our labels. Okay. So here we have features and we have our targets. Now it's time to split the data into the training and testing component. Here I am going to use a function train underscore test underscore split. And here I am passing my feature, my label. The testing size is 20% and random state is 42. Very, very standard stuff. You have seen this many times before now in this course. Let's run this cell to split the data. Now it's time to standardize the data. Here I am importing standard scalar from sklearn.preprocessing. Here I am instantiating my standard scalar and I'm calling this as a variable sc. Here I am fitting this standard scalar to my training component, and here I am standardizing my testing component of the data. So let's run this to standardize both the training and testing component. Now it's time to find the optimal value of k. So this is very important. In project 2, if you remember that we use 2 different methods in order to find the optimal value of k, that is using error rate plot and using grid search cross validation. So you can use any of the method in order to find the optimal value of k, because both method we saw in project 2 worked very well and their performance was very close to each other. So both methods are compatible to each other. So here I am using the error rate method in order to get the optimal value of k. You can also use grid search cross validation method as well. So the first step is, here I am creating the empty list for the error rate. I am running the for loop for 50 different values of k. So k is basically our nearest neighbor. Okay, here I am instantiating my classifier. Here I am passing nearest neighbor is equals to I. Therefore, when this loop is run for the first time, I will get the number of nearest neighbor is equals to 1. And for nearest neighbor is equals to 1, I will calculate the error rate. So basically, I am going to calculate the error rate for 50 different values of k. And I will select that value of k for which the error rate has the minimum value. So here I am instantiating my neighbor or my classifier. Basically, here I am fitting my model or my classifier to the training component. Here I am getting the predictions. Here I am calculating the accuracy. And after accuracy, I am calculating the error rate value. And here I am appending the error rate value to the error rate. So this is exactly the same code which you saw in project 2 of KNN. Let's run this cell. And now it's time to visualize the plot of error rate. And here I am getting the plot of error rate. So I have seen that at the start, the error rate is high, then it falls down, then again it gets the highest value, and it is vibrating between the two values. But when it reached to the value which is equals to 28, it has the minimum value for the first time. Later on, it has the minimum value for many numbers of k, but the first time it reached to the minimum value is when k was 28. So based on this observation, we will select the number of neighbors is equals to 28. So with n neighbors or nearest neighbor is equals to 28, I am again instantiating my KNN classifier and I am calling it KNN here. Here I am fitting this KNN to my training component, and here I am getting the predictions from the test samples. Okay, let's run this cell to train and test the model. Here I am comparing the predicted samples from the model with the actual labels of the testing component to get the accuracy. So we can see that again, we have the accuracy equals to 100%. So we have seen that the error rate plot is doing a great job in order to select the optimum value of K. So for nearest neighbor is equals to 28, we are getting the accuracy 100%. Let's plot the confusion matrix for this 100% accuracy. Here I am setting the font and the size for the font inside the confusion matrix. And I am importing the confusion matrix and confusion matrix display from sklearn.matrix here. And here I am getting the image of the confusion matrix. So let's run this cell. So we can see that this is our confusion matrix. So all the samples belongs to class 0, class 1, and class 2 are correctly classified. So they are along the diagonal of the confusion matrix, and we can see that there is no misclassification. So this is the confusion matrix. If the accuracy is 100%, all the values are along the diagonal and the misclassified values are 0. So in this project, we learn how to perform KNN classification on a wine dataset. The wine dataset has large number of features. That is, we have 13 features. Then we select the optimal value of K using error rate. We get the value of K is equals to 28. So 28 was the value of K for which the error rate has the minimum value. And then we perform KNN classification for K is equals to 28. We get the accuracy equals to 100%. And by getting accuracy equals to 100%, we plot the confusion matrix and we observe that this confusion matrix has the accuracy of 100% because all the values are along the diagonal, which shows the correct classification of the samples and there is no misclassified sample. So I hope you understood this project. Thanks for listening and I will see you in the next lecture. Hi everyone, welcome to this lecture. So in this lecture, we are going to solve our project 4 on KNN. So here I am in my KNN folder and this is my project 4. So click on this file so that we can open it in our Google Colab environment. So this is my project 4 in Google Colab. And in order to solve the project 4, I need NumPy, I need pandas. So I am importing NumPy as NP, pandas as PD. I need matplotlib. And similarly, I need kneighbors classifier. So I will import it from sklearn.neighbors. I also need train test split function. So I am importing it from sklearn.model_selection. Let's click on this cell so that I can import all the necessary libraries. Now, for this particular project, I am going to use the Titanic dataset. We have already seen this dataset in the logistic regression section. So here we are again going to apply KNN classifier on this dataset. So this dataset is present inside my KNN folder. And we know that in order to read the dataset from a folder, we need to mount the drive and we need to set the path. So the next step is to mount the drive. So we will mount the drive from here and we will click that we have to mount the drive. So Google will ask us for the permission. So we have to permit Google and now we can see that the drive is being mounted. And after this, we will set a path in order to read the dataset from the folder. So drive has been mounted. Let's refresh it from here. And here we are at our drive. So click on the drive. So inside drive, I have my drive. Inside my drive, I have a course material folder. And then inside the course material folder, I have supervised machine learning. Inside supervised machine learning, I have the folder KNN. And inside KNN, I have this dataset Titanic_train.csv. So this is present inside this folder. So I have to copy the path of this folder. So I will copy the path and I will paste the path here so that the path should be set and I will be able to read the data. Now the drive has been mounted, the path has been set. It's time to import the data. Now the data has been imported and we can see the shape of the data that it has 891 samples and it has 12 column. Let's see the first 5 sample. So we can see that this is our Titanic dataset And we have seen this data set before in the logistic regression section. So let's discuss this data set again. So here we have quite a few number of features or column. We have passenger ID, we have survived. Now this survived column will be used as a label. It has two values, 0 and 1. 0 means the person died in the Titanic accident, and 1 means survived. This is the passenger class. Okay, this is the name of the person, the sex of the person, age of the person, how many siblings the person have, and this is part, that is the information about the parents and children which are touring with the passenger. This is the ticket, this is the fare, this is the cabin number, and this is embark. Embark is the place from which, like we can see here, embark implies where the traveler mounted from. There are three possible values of embark for this data set, that is Southampton, Cherbourg, and Queenstown. And similarly, these are the information about the siblings or spouse. This is SIB, that is the information about the sibling of or spouse of a person on board. And part is the feature contain the number of parents or children each passenger was touring with. Now, there are quite a few number of features here, and we can see that we have categorical features as well. That is, sex is the categorical feature. Then we have embarked as a categorical feature. We have the features like age, which are in the number in the form of float. We have a passenger class in the form of integer. So we have quite a few number of features in this data set. Okay, now what to do with this data set? The first step here is check the number of passengers died. So survived is our label. This is our target value. So we have to check how many of the passengers died and how many of the passengers survived. So here I am reading the survived column of the dataset train survived dot value count. Let's run this cell and we can see that 549 of the passenger died and 342 survived. For survived, the label 1 is assigned, and for those passengers who died, the label assigned is 0. So the 60% of the passengers died. Now it's time to treat with the features. Now there are quite a few features which are irrelevant features like passenger ID, name, ticket, and cabin. So they are irrelevant features because they are not have influence on the labels, that is on the survived. That is, if the name of a person is something, it has no relation with the survived. Similarly, the passenger ID, the ticket number, the cabin. So these are the irrelevant features. So we have to remove this column in order to move further. So these are the columns. That's why I am dropping these from my data train.drop. And since they are column, that's why axis is equals to 1. In place is equals to true means I want the permanent change. Okay, let's run this cell. And now we can see that we have removed the passenger ID column, name, ticket, and cabin. Now it's time to check for the null values. So the data is train.isNull.any. Is there any null value? Let's run this cell. And we can see that there are two columns or two features where there are null values. The feature is age and the other feature is embark. So the difference is that age is a feature which are in the form of numerical values in the number, but embarked is a feature which is in the form of categorical data. Okay, so we will deal them separately. So how to deal the null values which are present in the column age? So what we are going to do, we are replacing the null value in the age with the mean value of the age. So we are calculating the mean value of the column age, and we are going to fill the null value in the column age with the mean value of the column, and we want to make it a permanent change. So here we are done with the column age. Let's check the null values again. And now we can see that there is no null value in the column age. So student, in the section of data pre-processing, we have learned already how to deal with the missing values, the null values, and the categorical features. So here we are using the same strategy. That is, we are calculating the mean of the column age and replacing the null value in the column with the help of this mean value. Okay. Now it's time to deal with the embark. Embark is the categorical feature. So what we have decided, since we have quite a few number of samples in a data set, that is 891. So we have decided to drop those rows of a data set where there are null values now. So null values are only in embarked. Now rest of the column, there are no null values. So train dot drop in place is equals to true. So we are dropping the null value. So the line of code is train, which is our data set, dot drop NA, dropping the null value. And then in place is equals to true. That is, we are going to drop the null values permanently. Okay, let's check the null values again. So we can see that there are no more null values and all the null values have been addressed. Okay, now check the data set. Now we have the passenger class, sex, age. The problem of the null value, which was in the column age and embarked, is solved. Now it's time to deal with the data which has the categorical features, that is sex column. This is the categorical feature and embarked is the categorical feature. So what we will do, we will creating the dummy variable for those categorical feature and we will drop the first column to avoid multicollinearity. So in the section of data preprocessing, we have learned in detail that after creating the dummy variables, why we drop the first column. So we drop the first column in order to avoid the redundant feature from the dataset, that is in order to avoid the multicollinearity. Okay, so I am creating the dummy variable for the column or the feature sex, and I am dropping the first dummy variable. That's why I write drop underscore first is equals to true. Similarly, I am creating the dummy variable for the embarked dataset, and I am calling it sex for the sex sex categorical feature, and for embarked feature I am calling it as embark. Let's run the cell to create the dummy variable, and here I am adding the dummy variable to my original data. That is, I am concatenating them along the column, and I am using the command pd.concat. That is, this is the concatenation function present in pandas. Let's run this cell, and now we can see that these categorical values, that is male and Q and S, that is Queenstown and Southampton, these are appear in our data set. Now, since we have already created the dummy variable for the column sex and embarked, it's time to remove this column because their representative are present in the form of dummy variable in the data set. So we are going to drop the column sex and embarked, and we are going to make it a permanent change on our data set. That is, we want to drop them permanently. Let's drop them and see the data set again. Now we can see that our data set is cleaned now. All the issues have been addressed. That is the issue of categorical feature and the issue of missing values. Okay, now it's time to extract the features and labels so that we can apply KNN classifier on this data set. So other than the survived column, all the other columns are our features. Therefore, if we drop the survived column, then rest of the features are our features. So let's click on this to extract the value of X, and survived column is our label. Basically, it is our target variable. Let's run this cell to extract the value of Y as well. So we have X, we have feature matrix now, and we have Y. It's time to perform train test split. For train test split, I am using a test size of 0.2. 0.2 mean I am going to use 20% of our data as a test and remaining 80% of the data as a training. Let's run this cell to split our data, and we can also check the shape of our test. So 178 samples will be used for the testing purpose. Now it's time to standardize the data. For data standardization, we are importing standard scalar from sklearn.preprocessing. And here I am instantiating my standard scalar. And here I am transforming my training data. That is, I am standardize my training data. And here I am standardize my testing data. Let's run this cell to get the standardized data. Now, before applying KNN classifier, it's time to find the optimal value of a K. We know from the previous projects that there are two methods in order to find the optimal value of K. Either we use error rate plot or we can use grid search cross validation. So here I am using the error rate. So the first step is to create the empty list of the error rate. Here I am passing the 50 different value for the K. Here I am instantiating my model, and I'm passing a nearest neighbor is equals to I. That is, when I will run this loop, the first value will be 1, then 2, then 3, then 4, it means I am calculating these values for 50 different value of k, and I will select the best value of k. And we know from the previous projects, the best value of k is that value for which the error rate will be minimum. Here I am fitting my KNN optimal to the training component of the data. Here I am getting the predictions from the testing component of a data, and here I am calculating the accuracy. And we know that the error rate is 1 minus accuracy. Here I am calculating the error rate value, and here I am appending the error rate value to my error rate list, which is here. Okay, let's run this cell to calculate the 50 value of the error rate, and here I am going to plot my error rate. So we can see that this is the plot of error rate. Let me reduce the size of this 8 by 7. I think it will be good. Okay, so we can see that this is our error rate plot. We can see that it starts from a very high value of the error, and on x-axis, if we increase the number of nearest neighbor, that is the value of k, it is decreasing, and then it is slowly and slowly decreasing, and it reached to the minimum value for the first time at this point. So at this point, k is equals to 14. So k is equals to 14 is the value of k where we get the minimum error rate for the first time. We also get the minimum value somewhere here, but first value is 14. The value of k is 14, for which we get the minimum error rate. So we select the value of k is equals to 14. So for nearest neighbor is equals to 14, I am going to instantiate my classifier. Here I am fitting my classifier on the training component of the data. That is, I am training my model on the training component. And here I am getting the prediction from the testing component of the data. Let's run this cell to train the model and to get the predictions. Here I am calculating the accuracy by comparing the prediction of the model with the original test labels. Let's see the accuracy. So we can see that we have the accuracy of 82% approximately, slightly above than 82%. Now, if we compare the performance of this classifier with the performance of logistic regression on the Titanic dataset, we remembered that in logistic regression section, we obtain the accuracy of around 77%. So here we get around 5% more accuracy than the logistic regression classifier. Okay, let's create the confusion matrix. So these are the font of the confusion matrix that I want the font size to be 15 and I want the font to be bold. So let's run this cell. Okay, so here I am importing a confusion matrix, F1 score, precision, recall value, accuracy, confusion matrix. I do not need a ROC curve here. Okay, so I can remove it. So let's run this cell to import confusion matrix, F1 score, precision score, recall, accuracy, and confusion matrix display. Okay, let's run this cell. Now it's time. So this is the repetition here, I guess. So we need to remove it. Yes. Okay, so we have already import. Now it's time to get the confusion matrix. And after getting the confusion matrix, we need to display the confusion matrix. So this will be the size of the confusion matrix. So this is very standard stuff. We have seen this code many times before, that how to display the confusion matrix. Let's run this cell to display the confusion matrix, and we can see that this is our true negative value, this is our true positive value, this is our false positive value, and this is our false negative value. So these are those values along the diagonal which are correctly classified by our classifier, and these are the errors or the misclassified values. So now we can also calculate the accuracy, precision, recall, and F1 score. So there is a typo, we can remove it here. Okay, now accuracy, precision, recall, and F1 score. So this is again the same line of code which we have seen many times now in this course. Let's run this cell. To calculate the accuracy, we can see that our accuracy is 82%, our precision is 81%, our recall is 80.5%, and our F1 score is also approximately equals to 81%. So we have seen that on this challenging data where we had a lot of features like categorical features, features in the form of integers, and there were also irrelevant features present in the original form of data. our KNN has done a great job by getting the accuracy of 82%, which is higher than the logistic regression classifier. So I hope you understood this project. Thanks for listening, and I will see you in the next lecture. Hi everyone, welcome to this lecture. So in this lecture, we will discuss few advantages and disadvantages of KNN algorithm. Let's start with the advantages of KNN. So the first advantage is that it is very simple to implement. We have already seen that there are only 4 points in KNN algorithm. Therefore, it is very easy to apply on any problem. So the first advantage is that this is a very simple algorithm. The second advantage is we can work with any number of classes. So if we have 2 classes in a data set or 3 classes or 4 classes, we can still easily apply KNN algorithm. So this is another advantage, that we can work with any number of classes. The third is that we can add more data very easily to our existing data set. Suppose we have a data set of 100 samples only, and we are applying KNN. And during the application of KNN, we want to increase the number of data samples in our data set. So we can do it easily. So this is the another advantage of KNN algorithm, that we can add more data to our existing data set. Okay, these are the few disadvantages of KNN. So first disadvantage is that it is computationally expensive. So we know that in order to apply KNN, we have to find the distance of a test sample with every point present in our dataset. It means we have to calculate a lot of distances. So a lot of computation is involved in KNN algorithm. That's why it is computationally expensive. So its performance is affected by high dimensional data. So in this section, we see the data only in 2D, that is a 2-dimensional data. But if the dimension of the data has increased from 2 to 3D or 4D, in that case, we have to apply the Euclidean distance in 3D or 4D, which is not easy to calculate. In that case, the performance is affected by the high dimensional data. That is, it might happen that KNN will not perform well if the dimension of the data is high, that is, it is 3-dimensional or 4-dimensional or any other higher value of the dimension. It is sensitive to the scale of data. So basically, if you remember, we calculate the Euclidean distance in order to find the nearest neighbor. So if we have 2 classes A and B, okay, let's understand this point here. If we have 2 classes A and B, and the coordinates of this class is very small, and the coordinates of data point of this class is very high. That is, it is in the range of tens like 3, 9, 7, 4. And it is in the range of 1000 like 990, 1100, 1200. In that case, if a new data points come and we calculate the distance between that new data point with all the data sample in our data set, in that case, we will get the small distance with class A, which has the small value of the coordinate, and large distance with class B, which has the large value of coordinates. So in that case, every time our data sample come, the class A will be assigned because it has the small value. So it will affect the scale of the data set. Therefore, in order to apply KNN, it is important to standardize the data so that the influence of a particular data sample could be removed. So I hope you understood the advantages and disadvantages of KNN algorithm. Thanks for listening, and I will see you in the next lecture.